This tree took 60 years to grow. In the next 8 hours, it will become the plywood in your kitchen table, your bedroom floor, the walls of new homes across the country, all from a single tree.
This is one of the world's largest plywood mills, where 1 million logs enter every year.
And 300 million square feet of plywood leaves. Let's follow the journey from forest to factory.
Modern plywood doesn't come from wild forests. It comes from tree farms, planted, managed, harvested.
This forest is certified sustainable. For every tree cut, 3 more are planted.
Foresters decide which trees are ready. Too young and the wood is weak. Too old and it's inefficient.
The ideal harvest age? 40 to 60 years. Old enough for strength, young enough for straight grain.
Sustainable forestry means continuous rotation. Some areas planted, some growing, some harvesting.
Douglas fir, southern pine, birch, different species for different plywood grades and uses.
Selected trees are marked with paint. This one is ready. Its neighbors stay for another decade. Roads are carefully planned. Minimal footprint, maximum efficiency. Every detail is calculated.
Streams get buffer zones, no cutting within 50 feet, protecting water quality for wildlife downstream.
Wildlife cameras monitor the ecosystem. Sustainable forestry means the forest stays alive.
But managing forests is just the beginning. Now comes the part that transforms standing trees into raw material. Modern logging doesn't look like old movies. No lumberjacks with axes. This is a harvester. One operator, one machine. It can fell, delimb, and cut a tree into logs in under 60 seconds. The cut is precise, angled to control exactly where the tree falls. Safety and efficiency combined. 60 years of growth meets 6 seconds of technology. The tree is down. The harvester strips branches instantly. What took crews hours now takes seconds. Onboard computers measure and cut optimal lengths. 8 feet for plywood veneer. Precision matters. Skidders collect the logs. These machines can carry 20 tons through rough terrain. One load, multiple logs. Every trip maximizes efficiency and minimizes forest disturbance. Skid trails are planned to reduce soil compaction. The forest will recover within years. At the landing zone, loaders stack logs onto trucks. Each truck carries up to 40,000 pounds. The logs begin their journey, 40 miles to the mill. In 3 hours, these trees will be unrecognizable. The log yard, where millions of dollars in raw material wait their turn. Organized chaos. Every truck is weighed and logged. This load, 42,000 pounds of Douglas fir. Each log is graded on arrival. Species, diameter, straightness, quality determines destination. Giant stackers sort logs by grade. Premium logs become face veneer. Lower grades become core layers. Some mills use log ponds. Water keeps logs fresh and begins softening the wood fibers. Sprinklers run constantly. Dry logs crack and split. Moisture is money in this business. Before processing, bark must go. This debarking ring strips it clean in seconds. That bark isn't waste. It's fuel for the mill's power plant. Nothing is thrown away here. Clean logs head to conditioning. The wood needs to soften before it can become veneer.
Steam conditioning at 200 degrees, 12 to 24 hours. This makes the wood pliable. Inside those vats, wood fibers are relaxing, preparing to be peeled into sheets thinner than cardboard. The lathe room. This is where logs become veneer. the most critical step in plywood production.
Each log is centered on the lathe. Millimeters matter. Off-center means wasted wood. The operator sets thickness. 1/10 of an inch for face veneer. Thicker for structural cores.
The blade is carbide tipped, razor sharp. It must be perfect, or the veneer tears.
The log spins at 200 RPM. A continuous ribbon of veneer peels off like paper from a roll. What took 6 years to grow is now a sheet 1/10 of an inch thick, peeled in minutes. The veneer ribbon travels down the line. One log produces up to 200 linear feet of veneer. Clippers cut the ribbon into sheets, 4 feet by 8 feet, the industry standard panel size. Sheets stack automatically. One lathe produces thousands of sheets per shift. Continuous production.
Look at that grain. This is why wood remains irreplaceable. Nature's fingerprint in every sheet.
Inspectors check every sheet. Knots, splits, voids, defects determine grade and destination. Defects don't mean waste. They get patched or become inner layers where appearance doesn't matter. 6 lathes running together process 1 log every 30 seconds. Scale is everything here.
The core that remains? Just 3 inches diameter. 95% of the log became veneer.
But wet veneer can't become plywood. First, it needs to lose half its weight in water. The dryer, 300 feet long. Wet veneer enters one end. Dry veneer exits the other. Sheets enter on rollers. The journey through takes 15 to 20 minutes, depending on thickness. Inside, temperatures reach 350 degrees. Jet nozzles blast hot air from above and below. Moisture sensors track every sheet. Target is 6% moisture content. Precision drying.
Dry veneer weighs half what it did going in. All that weight was water that's now steam.
Now grading. Human eyes decide the fate of every sheet. A grade, B grade, C grade, shop grade.
A grade has minimal defects. Smooth grain. This becomes the face you see on furniture.
Lower grades become inner layers, hidden between faces. Every grade has a purpose.
Patching machines fill holes and repair splits, salvaging value from imperfect sheets.
Sorted and stacked by grade. Millions of sheets organized, ready to become plywood panels.
Dry, graded, sorted. Now these thin sheets will be glued together into something incredibly strong.
The glue line, where veneer sheets become plywood panels. Chemistry meets craftsmanship. Phenolic resin, waterproof, heat resistant. This glue will outlast the wood itself. Spreader rollers apply exactly the right amount. Too little means weak bonds. Too much means waste. The glue penetrates wood fibers. When cured, the bond is stronger than the wood around it.
Now the layup. This is what makes plywood strong. Alternating grain directions in every layer.
Each layer is perpendicular to the last. This cross-grain construction prevents warping and splitting.
Standard plywood has odd layers, 3, 5, 7. Always odd, so both faces have matching grain.
Alignment must be perfect. Offset layers mean trimmed edges, wasted material, lost profit.
Assembled panels head to the press. Right now, they're just loose sheets with wet glue between them.
A cold pre-press removes air and sets initial contact. Prepares the assembly for heat. Glue squeezes to the edges. This is good. It means full coverage between layers.
Last chance to catch errors. Wrong layer count. Misaligned sheets. After pressing, it's permanent.
Even at room temperature, the glue begins reacting. Full cure requires heat and pressure. The hot press, where heat, pressure, and time transform loose layers into a single solid panel.
The hot press. 40 openings. 20 panels per opening. 800 panels cured simultaneously. Automated loaders slide panels into each opening. Every slot filled for maximum efficiency.
The platens close. 200 psi of pressure. The assemblies compress to final thickness.
300 degrees Fahrenheit. The heat activates the phenolic resin. Molecular bonds forming.
Operators monitor every variable: temperature, pressure, time. Deviation means defective panels.
4 to 7 minutes under heat and pressure. Too short and bonds fail. Too long wastes energy. Pressure must stay constant. Fluctuation creates weak spots where layers can delaminate. Cycle complete. The press opens. What entered as loose sheets exits as solid plywood. Panels unload while new assemblies load. The press never stops during production hours. Touch it now and it's hot. But the glue has cured. These layers are bonded for life. But we're not done yet. The panels need to cool, stabilize, and be finished to perfection.
The finishing line, where pressed panels become the plywood you buy at the store.
First, cooling. Hot panels warp if handled too soon. 24 hours of stabilization. Edge trimming cuts panels to exact size, 4 by 8 feet, within 1/16 inch tolerance. Sanding drums smooth both faces. 120 grit creates the finished surface.
Feel that surface. Smooth enough for direct finishing. No splinters. No rough patches.
Thickness is verified at multiple points. Must match the rated dimension. No exceptions.
Ultrasonic testing finds hidden voids. Delamination invisible to eyes shows clearly on the scan.
Proved panels get stamped. Grade, mill number, certifications.
This stamp is legally binding. Rejected panels? Some are downgraded. Some become chips for particleboard. Nothing wasted.
Proved panels are bundled for shipping. 60 panels per unit, ready for distribution.
8 hours after entering as logs, the wood leaves as plywood. But the story goes deeper than that. A sheet of construction plywood sells for $30 to $50. Here's where that money goes. The timber company receives about $8 per log. For 60 years of growth and management,
Mill workers earn competitive wages. This facility employs 300 people year-round.
The mill generates its own power, burning bark and waste wood, reducing outside energy costs.
Sawdust becomes particleboard. Chips become pulp for paper. Bark becomes mulch. Zero waste. For every tree harvested, 3 seedlings are planted. The forest regenerates continuously.
Replanting happens within 1 year of harvest. In 60 years, this area will be harvested again.
Managed forests absorb carbon. The plywood stores that carbon for the life of the building.
certification programs verify sustainability. Look for FSC or SFI logos when you buy. This plywood will become homes, schools, furniture, storing carbon for 50 to 100 years. Managed forestry and modern manufacturing. When done right, it's not destruction, it's transformation. 60 years of growth, 8 hours of processing, decades more of useful life. That's the plywood cycle. The table where you eat dinner. The floor beneath your feet. The walls around you right now. Somewhere today, A tree is being planted that your grandchildren might use. 1 million logs, 300 million square feet, the world built on wood. And now you've seen how.